As I've mentioned in the introduction, there is another aspect of the challenge that we want to give you with this exercise, and that's the active streets. So in addition to the smallest number of total travel distance, you shall generate as many as many active streets as possible. So the length of the active streets shall be maximized. What are active streets? Active streets are the streets that are used most often. So you can consider them as kind of lively streets. When you have more traffic, we can expect more activities on the street. And that's something we want to generate because these streets, they can be used for commercial activities. These would be the streets where you place small shops, bakeries, or small shops that sell something for the daily usage. This would be the ideal place for these kind of commercial activities. You can see the active streets that you generate by your land use pattern. We defined a certain threshold for it, a certain number above which we consider a street as active. So you see this, if you activate the component show active streets here in this visualization box, activate the preview, then it overrides the network centrality analysis and it shows you which streets are considered as active. So these are these ones that are above the certain threshold for the betweenness centrality in terms of the network centrality measures that you know. You can also show the corresponding plots. So here the red ones, these are the plots that are connected with one side at least to one of these active streets. So these are the plots where you could place commercial activities to be connected to active streets. That's the idea. So if you scroll in here, then you see the length of the active streets. That's the second number that we want you to maximize. So you shall minimize the total travel distance and you shall maximize the length of the active streets. Because in this model, we just consider that it is better to have more active streets and it makes it more difficult for you to find a good solution because, of course, these two measures, they contradict each other. But try to achieve a pattern with the minimal or with a very small total travel distance and a very big length of active streets, a very large number. So again, these are the baselines that you have to beat. So for the average distribution of the land uses, 1,490 units of travel distance and 776 units of length for the active streets. You should be better. Below you see just a distribution of the streets. So we have chosen the threshold 100. So these few streets that you see, they are above the threshold and many others are below the threshold. After you've drawn a land use pattern, you may want to save it. Therefore, I provided you these load and save components. In the beginning, there should be a file that's filled with the equal distributed land use pattern. This is provided by the download with the file for this exercise. So with the definition, you have a GH data file. If you right click on this input component, you will see this source menu item. And if you open it, then you find a file browser, and this file should be part of the zip file that I sent you, or that you downloaded here. And this contains the data that you store in this component. So land use data underline network, that's how I called it. You can also create a new file name and a new file if you want to store individual versions of your land use patterns. Then you just have to make new files. As long as you use this file, that's what you also used for save. But that's what's loaded if you press this load land use button. So now we don't see any change, but if I reset it first and load it again, then you see that this equally distributed land use pattern. If you draw your own distribution, so just let me delete a few of the population units and maybe also workplaces, just that we see a difference. Now we want to draw again population units only here and some here and a few here and workplace units as well. So just to have a different pattern that you see how you can save it. To save this version of your pattern, what you have to do is to enable the output. Now your pattern is saved, and if you keep it enabled, it will save all changes that you make. So if you say you delete a few workplaces from here and you want to, oops, something's wrong. You want to add them, I don't know, here. We are still again at 100%, and this should be updated. And if we now disable it again, we disabled the updates as well. Here, the same procedure as with the input component, you have this destination. If you just click on this, you see the file path to the destination of your file. And that's where you create a new file. Apologize, in before you loaded it only. Here you can create a new file. If you enter here a new data name, then you create a new one. And if you want to load this new one, you just have to select the same file here. And now just remember this pattern. If we press reset and load it again, then it should be the same pattern that we have had in before. So that's the load command that we have here. It may happen that the equally distributed land use pattern is not working in your case. Then I just show you briefly how you can generate this equally distribution on your own. Therefore, you have to go to this blue bubble group, the boundary conditions. And now you have to do the same, or you have to be careful that you follow the same sequence that I show you now. So you first have to activate the save equal distribution component. Here again, the same thing, you can define the path. So be sure you know which file you use to store the information. And after you activated it, you have to enable, so you have to set this Boolean toggle to true, create equal distribution. And then you see here, I have set my definition and then that I see the time that the component needs to run. So this tells me, okay, now something is saved. Now you have to deactivate first this save component and only afterwards set this to false again. So if you don't do it in the same sequence that I've done it, you may overwrite this output with an empty pattern or with something that you don't want to get. And now I stored it. I use the same file name as I use here. And if I reset it and load it, then you see you have again loaded the equal distributed land use pattern. That's basically everything you need to know in this definition. All important aspects that you need to draw your land use. I've introduced them to you. Now you just have to find the ideal or a very good land use pattern.